To continue on sampling, Module 9 focus on parametric sampling methods. Previously, the question how many respondents shall compose the study sample, that's already answered in the previous module. And the sample size already determined through these two steps. First, the study population or universe you already have defined, and the sample calculated already using a sampling formula. It is at this point when the appropriate sampling method is decided. Now, sampling methods can be non-probability sampling, especially for those qualitative studies, or probability sampling for us in this course, which is focused on quantitative methods or research method. So we have under probability sampling, simple random, stratified random, systematic, cluster, and multi-stage. We are going to take this one by one. Now, probability sampling, all members of the population have an equal chance of being selected in the sample. The fundamental idea here is that there is provision of useful descriptions of the total population. A sample of individuals from a population must contain essentially the same variations that exist in the population. That's why we call the sample a representative of the population. Now, the uses of probability sampling is when researchers want precise statistical descriptions of large populations. Example of large population voters, young adults from 14 years old to 25 years old, reproductive mothers, age 15 to 45 years old. For large scale surveys. And also probability sampling is can serve as basis for developing of policies that affect large populations, like company policies or government laws. Let's take first the simple random sampling. This is widely used, wherein every element of the population has an equal chance to be selected as a source of data. So it's like a lottery type selection where every source of object is identified by means of a tag placed in a container. And the tags are thoroughly mixed and drawn. May use the table of random numbers, which we will take late in a while. Now, stratified random sampling is used when there is ready list of the universe whose members are classified into certain categories, like the category of students, there are faculty, and there are staff, as in the case of MSU constituents. The procedure would be to get a list of the universe, decide on the sampling size or the actual percentage of the universe that should be considered as sample. Get an equal proportion of sample from each group. Remember, you already have determined the number of the sample from your calculation using the sampling formula. Example, suppose there are 200 students, 300 faculty members, and 500 staff. Okay? Now, you're going to have, this is the population, no? From the 1,000, you're going to have a sample of 100. So in proportion, you're going to have an equal of 10% from each of the category, and thereby you'll have 20 from 200 students, 30 from 300 faculty members, 50 from 500 staff. Um, from the 100 respondents, either by simple random sampling selection or systematic sampling. Now, what is systematic random sampling? Used when there is already list of the total universe or population. It is a functional equivalent of simple random sampling and usually easier to do. For example, get a list of the total universe or population. Divide it by the desired sample size to get the sampling interval. So, if the total population is 5,000 and the desired sample is 100, just an example, you're going to divide 5,000 by 100. So you have 50 as sampling interval. So get number 50 as the first sample, and every 50th person in the list would be the next to constitute the sample. So 50 is the first in the sample, followed by 100 person, the 150th person, the 200th person, and so on until you reach 100 respondents out of the 5,000. So that is systematic random sampling. Also, if you're going to consider subdivision, for example, you are going to have 5 as the sampling interval. So every fifth house in the particular subdivision will be your household sample. Cluster sampling, used when there is an area where the results of several surveys on certain issues virtually match national results. The procedure would be, okay, natural groups as clusters are sampled initially, with the members of each selected group being sub-sampled afterward. For example, students from Philippine colleges and universities first select a sample of Philippine colleges and universities from a directory. Then, get list of the students at all the selected schools. Third, draw samples of students from each of the school. The multi-stage sampling involves repeating of two basic steps, listing and sampling. Lists of primary sampling units for like churches or blocks in subdivisions is compiled and may be stratified for sampling. A sample of units is selected. The selected primary sampling units are then listed and may be stratified. The list of secondary sampling units is then sampled. For example, a population area of a city. First stage is you select a sample of blocks. Second stage, you list the households on each selected block. The third stage, you now obtain sample households. The fourth stage, list the people residing in each household. The fifth stage is to obtain sample persons within each selected household. That's the multi-stage sampling. Now, these different sampling methods that we have mentioned, simple random, stratified random, the systematic, the cluster, and the multi-stage sampling, you can combine them depending on which may be appropriate to the study. Now, using the table of random numbers, to recall, you have first determined your sample size through a formula, then decided the appropriate sampling method for your research. In the selection of the actual sample, the table of random numbers can be useful. Suppose you want to select a simple random sample of 100 people out of a population totaling 890. Remember, the population is just 890. Now suppose this is the table of random numbers. Actually, there are so many versions of the table of random numbers. We're going to use this version. So you see, the table is composed of rows and columns. There are 30 rows and there are 32 columns. Okay, suppose you are going to say, look at column 5, row 8. Column 5, row 8. So the number is 5. Okay, now we are going to say, look at column 28, number 5. So the number is 0. Okay, let's now begin. Step 1. Number the members of the population from 1 to 890. Remember, the population is up to 890. Not necessary if you have them in a list that clearly totals to 890. Now, second, determine the number of digits you'll need in the random numbers you select. For 890 population, you need 3 digits or 3 columns because each of the column here has 1 digit only. So you select 100 random numbers in the range from 001 to 890. Now, third, refer to the table of random numbers. This one, create 3-digit numbers from the 3 columns because you need 3 columns, right? Follow a pattern in moving through the table to select numbers. Decide where to start. So you follow a pattern like going downwards or going upwards. Make a plan and stick with it. Sample plan. Use the rightmost 3 digits in each case. So you go right. Choose numbers all the way down the column until 100 cases are selected. Okay, this is the plan. You go right and then choose numbers downwards. Action. Close your eyes and stick a pencil into the table and start where the pencil point lands. And this is really what you are going to do as a researcher. Now, suppose it landed on row 7. Row 7, row 7. This is row 7. Okay. Of column 6. Row 7 of column 6. Okay. So what's the number? The first digit is 1. Okay. And using the next 2 right digits, 0 and 4. Because you remember the plan, you go right, okay, for 3 digits. You just need to determine the first digit. Then you go right and choose the next 2 digits to have 3 digits. So you now have 104. So the first sample unit is 104. Going down, the next sample units will be 820. Skip those bigger than 890. So 104. So since the next number digits are 996, these are not included because we only have 890 population. So there is no more after 890. So the next to 104 would be 820. Continue downwards until you reach the desired total sample, which is 100. Remember to skip the numbers that are bigger than the population. So the next would be 519, 869, 417, 200. Going down. So we have 19, 617, 759, 714. And we have these next digits. So 216, 516, 103, 697.